Hi STEMers, I want to do a quick video now on working with, as our title suggests, negative exponents, negative integers, and how those work when we're working with exponents and parentheses. All right, so I wrote our GEMDAS math model on the sides, which stands for grouping, exponents, multiplication, division, which are on the same level, and addition and subtraction. So that's the order of operations we will follow. What I want you to do is pause the video and put a box around what you believe are the base values of each of these 6 different expressions. So pause now, put a box around the bases, unpause when you're done. Okay, so hopefully, now I realize you can't write on the screen, but I wanted you to at least kind of mentally do that. The bases here are basically everything that the exponent applies to. So for the first one, the exponent applies to the 3. In the next one, the exponent will apply to everything in that parenthesis because the entire value is raised to the exponent. Down here, it would just be the 3 because the negative sign is not contained within the parentheses to which the exponent applies. So here the base is 3. The first one, the base was 3. In our second one, the base was negative 3. All right, now these next two, again, the base is whatever's in front of it, unless there are parentheses that group that together. So here the base that the exponent applies to would be this negative 3 right here. Okay? The negative out front is not a part of that base. It's only what's within the grouping symbol. And so you can see on the next two, again, we'll have a base of negative 3 on this one. And then the last one, since there's no parentheses around the negative, only the 5 is the base. And that's, if you can answer that question, you'll have no troubles. Once you identify the base, that's the part that gets repeatedly written out to simplify in our multiplication. All right, so on the top one, I'm just going to repeat the 3 4 times because the exponent tells us how many times to write that in terms of multiplication. All right, and if you do a little mental math here, 3 times 3 is 9. 3 times 3 here is 9. So if I replace those with 9s, this would be equal to 81. All right. On the second one, since my base is negative 3, that will be the value that gets multiplied 4 times. And based on what we talked about just a minute ago with the negatives, every set of negatives becomes a positive. So we got a positive 9 times a positive 9, which still ends up equaling 81. Even though it was a negative base, it got multiplied an even amount of times, so it ended up positive. Okay? The next one, only the base gets recorded 4 times. So my base is 3, but since there's a negative out front, that means change the sign when you get done with your multiplication. So we already calculated that this would be 81, but since there's a negative out front, that makes the entire product negative after we do the multiplication. I've seen some students think of this as negative 1 times 3 to the 4th, and that's a perfectly legit way to evaluate that. So if that makes more sense, it's another way to think about it. We could do the same thing here. You can put an integer of 1. We could put a negative 1 out front, and then we're going to take our negative 3 and repeat it 3 times. So now if I count, I have back-to-back negatives. That becomes a positive 3. And then with the next two values, next two factors, we end up getting a negative times a negative, which is a positive. So a positive times a positive ends up a positive. All right, so we can't just look at this and go, oh, 2 negatives turn into a positive. It really, we got to follow PEMDAS first, or GEMDAS, to see how it ends up. All right, and the last two, negative 3 is going to get recorded 3 times, so I'm kind of running out of room, negative 3, since that's my base, that's what I repeat 3 times, and if you count, we have an odd number of negatives, so my overall answer is going to be negative 3 times 3 is 9, times 3 is 27, so we end up with a negative 27. All right, similar to what we did up here, if the negative is outside of the base, that is the last thing you do in terms of following GEMDAs. So I'm going to do my exponents first. So I know I'm going to repeat my 5 twice. And then I'll make this answer become the opposite sign. So 5 times 5 is 25. This negative makes the entire product the opposite of what it originally was. So since it was negative, now it's positive. Thanks for watching. Let me know if you have questions.